So what is the scientific method? According to the University of California at Riverside, the scientific method is a process that involves observing some aspect of the universe and then generating a hypothesis based on your observation. You then use that hypothesis to make predictions and test those predictions by experimentation or further observation. You may have to repeat these steps until there are no discrepancies between theory and experiment or observation. And then after that, you make a conclusion about your results and either reject or don't reject your hypothesis. So why do we need the scientific method? It is an evidence-based method for acquiring knowledge about the universe. It helps us solve phenomena through respectable, empirical, and reasonable experimentation. It is a set of guidelines that work to help solve the phenomena that exist in our world today. But one needs to be wary of pseudoscience when applying the scientific method. According to University of Texas, science's goal is to achieve a more complete and unified understanding of the physical world. It involves intense research, which result in the continual knowledge expansion within the discipline. Workers seek out counterexamples or findings that appear to be inconsistent with accepted theories. Hypotheses can be disproved if new data or substantial evidence is found against the accepted theory. Every aspect is tested and still remains subject to be questioned at any time. Concepts and ideas must stand within its own merits based on existing knowledge and evidence. Scientific explanations must also be stated in clear, unambiguous terms. The difference between science and pseudoscience is that pseudoscience is driven by ideological, cultural, or commercial goals. The field has evolved very little since its first establishment. Small amounts of research and experimentation that is carried out is only used to justify the belief rather than extend it. Any observation or data that is not consistent with the established beliefs tend to be ignored or suppressed. Principles of the field are often not falsifiable and are unlikely to ever be altered or shown to be wrong. Concepts tend to be shaped by individuals' egos and personalities, mostly by people who are not in contact with science. Any explanations tend to be vague and ambiguous, often invoking scientific terms in unusual contexts.
The history of the scientific method goes all the way back to ancient times. It took thousands of years to figure out how to properly practice the discipline of science and how to organize all of the necessary steps. Aristotle is given some credit with creating the scientific method because he was the first one to suggest that if you want a question answered, you need to go out and make observations. His theorem of empiricism was based on the foundation of other scientists, pooling the knowledge and new discoveries they acquired into a communal database for others to utilize and grow off of, helping the scientific community progress and work on experiments that have yet to be done instead of unknowingly repeating experiments. Despite the fact that Aristotle receives some credit, the actual founding of the method is given to Ibn al-Haytham, who did a lot of work on light and optics. He developed a method on his inquiries, which was founded on gathering data through observation and formulating hypotheses. Abu Ali al-Hassa, a Moroccan astronomer and mathematician, is given the credit for the words hypothesis and theory, and the idea that you can try and answer a question and then show that it's true.
To begin the process of the scientific method, one must question a natural occurring phenomenon, such as why are ants attracted to candy. The next step is to perform background research and learn more about the question being asked, and then construct a hypothesis around the existing research. For example, ants are attracted to sugar, but a hypothesis question could be, are ants attracted to other flavored candies, such as spicy or sour, as strongly as they are sugary candies? The next step is to devise a test for your hypothesis to be tested against a control. To test what kind of candy ants are attracted to, a simple experiment involving placing a sour warhead, a spicy fireball, and a sugary mint in an area ants can freely wander and choose in between candies. The next step is to make sure the procedure is working and ask if there are any other improvements to the experiment. The next step is to analyze the data obtained and either construct a new hypothesis if the data does not align, or to communicate your results with the scientific community if they do.
One of the great errors in the public understanding of science is to equate settled with proved. While Einstein's theories are settled, they are not proved, but to plan for them not to work would be utter folly. Those who demand the science be settled before we take action are seeking certainty when it is just impossible to obtain. And demanding certainty before taking action does not make us strong. It paralyzes us.